So that trig substitution was so much fun. Let's do it all again, shall we? So for this problem, we want to use trig substitution, and it's not immediately obvious that it fits into one of those formats because it doesn't seem to be any one of them. But you have your old standby and mine, algebra class, right? We all took it. We all suffered through it. Let's think about this. I have a trinomial. If only I could turn that trinomial, hint, 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 into a perfect square. I'm going to complete the square. That's what I'm going to do. All right. So we're going to complete the square. So let's see here. X squared plus 6x plus, and the way it works when it's not an equation is you have to add and subtract the same amount, and then we'll add the 18 out at the end. So we're going to add and subtract something away. Something that'll make this turn into a perfect square. It'll make it x plus something. I can tell it's plus because the 6 is positive. All right, so, well, let's complete a square. So if I take 6 and divide it by 2, you take the middle term, or the linear term, I should say. So 6 divided by 2, and you square it. It's 3 squared, which is 9. So we're going to add 9 and subtract 9. And that'll mean that it's x plus 3 over here, because 3 times 3 would get us 9. 3 plus 3 would get us 6. We've turned it into a perfect square. And then the two back numbers right here, negative 9 plus 18, makes 9. Right? So if you want to write a little note to yourself, that's negative 9 plus 18. Right? Negative 9 plus 18 makes 9. Okay, but now it's fitting into one of our formats. If we look at our trig substitution formats, it's looking a lot like x squared plus a squared, right? Although it's u, right? We have a kind of a u substitution going on here. So this would be equal to u squared, and this would be equal to a squared. So a is equal to 3. So if I write this out, that's u squared, and that's a squared, right? And so u is equal to x plus 3, a is equal to 3, and we'll be able to use that over in our trig substitution, which is what I'm about to do. All right, so our substitution that we're going to make on this one is right here. The tangent of theta is equal to, in our case, it'll be u over a. Tangent of theta is equal to u over a, which will be x plus 3 over 3. All right, now I can use all of that knowledge that I have gained, and I can make a triangle, and I can do all of that good stuff. All right, so let's think about that triangle. If I have an angle theta, the tangent of theta is the opposite over the adjacent. Oh, sorry, that's a 3. It looks weird. So that means that the opposite over here is x plus 3. The adjacent right here is 3. And then I can use the Pythagorean Theorem to find the other side, which I will do. So Pythagorean Theorem, if I call this h, because it's the hypotenuse, 3 squared plus x plus 3 squared makes h squared. So h is equal to the square root of x plus 3 squared plus 9. So this over here is the square root of x plus 3 squared plus 9. Like that. All right, what else do I know? Sorry, I want to circle that because that's my trig substitution. I don't want to lose sight of it. I should have done that in the previous example as well, because that's the big one. Everything else falls out of the fact that that's what I'm using. So if the tangent of theta is x plus 3 over 3, that means that x plus 3 is equal to 3 tangent of theta. So x is equal to 3 tangent of theta minus 3. So that's what x plus 3 would be. That's what x would be. And then dx is the derivative of that. Dx would be the derivative of tangent. is secant squared. So it's 3 secant squared of theta. The derivative of 3 is 0, so that's gone. And then d theta. So that's dx. I'm going to need that piece for that numerator up here, dx. And then theta would be, well, let's see here. If the tangent of theta is, it's right here, tangent of theta is x plus 3 over 3, then theta would be the arctangent of x plus 3 over 3. So we'll just kind of keep that in mind. All right, so there's all the pieces that we may need. We may need other pieces. If we need cosine or sine, we can come back to the triangle and always build them ourselves. All right, so I'm going to keep that all on the side, right? Because that's all the extra work that we're going to use to inform our integration here. All right, so now let's look at our integration. We have dx over x plus 3 squared plus 9. Okay, so, and actually, let me rewrite this just a little bit, just to kind of, because putting dx in the numerator is not actually that useful most of the time. It's just a lazy person, right? They just don't want to write 1 up there. All right, so let me rewrite this. This is 1 over. Okay, now x plus 3. You could substitute in x, but x is 3 tangent of theta minus 3. And then if you add 3, it is just going to go away. You have it right here, right there. You can use it, right? So this would be 3 tangent of theta squared, right? The plus 3 is taken care of because x plus 3 is 3 tangent theta. So that's taken care of. And then plus 9. And then dx was calculated down here. Dx is right here, right? So that's the second piece we're using. It's 3 secant squared of d theta. So that dx right here is 3 secant squared of d theta, of theta d theta. Always have to have an angle for your trigonometric function. So just so we're clear, that's the single star, that's the double star, right? That's the substitutions we're making. This is dt right here, or dx, sorry, dx. And this part right here is x plus 3. Sorry. Right, that's the double star substitution right there. And then this is x plus 3. And that's the single star substitution we're making, just so everybody gets what we're doing. And again, why? Well, because you can. I mean, basically, before calculators and computers were invented, people had to figure out how to do these integrals. They played around for a really long time and found these patterns. People with no TVs and calculators basically have way too much time on their hands. That's what the answer is. All right, so this is the integral of, and I'm just going to distribute this. So this is 1 over 9 tangent squared of theta plus 9. And then it's a 3 secant squared theta d theta. All right, well, I noticed that there's a 9 in both of those terms, so I can factor the 9 out, and I can bring the 3 to the front. Matter of fact, I probably should have anyway. Here, I'll just put 3 right there. So I'm going to factor a 9 out. So that would make 3 over 9 integral 1 over tangent squared theta plus 1 secant squared theta. I mean, once you do the substitution up here, it's basically, it's your wits, right? It's algebra and factoring and completing the square and trigonometry and everything you've ever learned, right? All that stuff we reviewed in 8.1, that's what you have at your disposal. So that's what I'm using. And a little bit of 8.3 with, powers of trig functions and stuff like that. All right, so this is 1/3. And when I see this, I instantly think, oh, Pythagorean identity, right? I know what that is, right? Tangent squared plus 1 is secant squared, right? That's the Pythagorean identity. So this is 1 divided by secant squared times secant squared. Hey! Secant squared divided by secant squared, they're going to divide away to 1, and that means that I have 1/3 integral of 1 d theta. Or you could just write d theta if you want to be extra lazy about it. And the integral of 1 d theta is just theta. I'm going to add my constant of integration because I've done my integral right there. And I can't leave it in terms of theta. I have to go back to the original, what the plan was here. But luckily, I have it right there. So if this bit right here was my first substitution, and this was my second one, then the third one I'm going to make is right here. Right here. It's going to go right back in there. And so where theta was, I will write arctangent of x. Oh, I meant to write it in orange. Sorry. Or just underlining in red. All right, so the arctangent of x plus 3 over 3. That is the correct integral for the original problem that was given. It's amazing, isn't it? And again, you were not capable of doing that problem any other way. There is no rule that you've learned so far that would have helped you with this problem other than this method.